Hello, happy Valentine's Day, everybody. And happy Ash Wednesday for those of you who follow religion. Yes, it's the beginning of Lent. So, what I'm going to do first, we're going to finish up chapter one. I'm getting tired of chapter one. We've been on it for too long. So, I'm giving this out. This is over the first half of the chapter, because I know we may have forgotten how to do this. Look over this, and I will send you the solution to these when I send you the videos. Okay, so just practice those and see what you know. Because imagine if this was a test coming up. I mean, again, this is sections 1, 2, and 3. You should at least know this much already. So if this was part of the test, how well would you have done? Before I move on, are there any questions about any of these, what these are asking? Any questions about it? The first four are determine whether they're true or false. Sasha says, determine whether each of the following are true or false. The x-intercept of the line passes through this, blah, blah, blah. All functions are relations, but not all relations are functions. Line parallel to the y-axis passes through the point this. That's the equation. And the last one. Okay, the next two, or next four. For each pair of points, find the distance between the 2 points and the midpoints. And the last four, graph the equations. And this tells you what section they're from. So that's what I'm saying is this could have been an easy quiz or a test I could have given you all because this is earlier part of the chapter. Right. So it's not due to anything, but it's just for your practice to see how well you're doing, how well you know. I also this week they opened up the progress reports. So this weekend, I'll go ahead and send you all your progress reports. Again, it's either going to be satisfactory or unsatisfactory. You're satisfactory if you're up to at least to section 1.5, 1.6. If you're there, you're satisfactory. If you're not there, you're unsatisfactory, meaning catch up. Because we've been on those sections forever. So don't get stuck on them. All right. So what we're going to do here, we're going to finish up 1.6. Remember what we did last time? Yep, very good. Inequalities. Any questions about it? Okay, so I'm going to give you a problem. Let's make that 5x. So go ahead and solve it. I want the answers. I want the graph of the answers. And I want all three of those simplified. This question, where should you focus? What should you focus on first? Yeah, well, what you focus on is the middle part. Whatever you do there, you do those other two parts. So you're getting to what you're trying to get x by itself, right? So what do you do first to get x by itself? Yeah. Multiply by the LCD. Two times 4 is 8. The 2's cancel. 2 times 9 is 18. That's the first step. Second step. Subtract 3. 8 minus 3 is 5. 18 minus 3 is 15. Now what? Change everything. Change this sign, change that direction, change that sign, change that direction, change that sign. Flip everything. Then divide by 5. So this is -1 greater than or equal to x greater than -3. Leave the answer like that? Yeah, because it has to be reading left to right, smaller to larger. So we have to flip the whole thing. So we have -3 x and -1. The pointy arrow points at -3. The pointy arrow points at x. So there is what notation is that? That's set notation. That is it? What's interval notation? With the brackets and parentheses. Yes, this is set notation. How would you write this in interval notation?
Parentheses -3, comma.
Right. So the endpoints are -3 and -1. The -3 is not included. The 1 is included. And the graph, do I use -3? No, so it's an open circle. And -1 I use, and my x is between there. So there's the graph. Okay, here's another question. So here is the next thing I want you to do. There's the graph. Give me the set and interval notations. All right. So what would the set notation look like? Very good. Because this one goes to -infinity. And that's your set notation. What would the interval notation look like? Very good. Because the shaded region is your X. This one says X, since it's shading to the left, X is less than -4. X is between 3 and 7. I don't want you guys just to rubberneck. You guys are supposed to know how to do this already. I noticed some of y'all are just waiting to put it on the board. I'm sorry, but that's not how it's going to work. I don't want to get it to a point where I'm saying, okay, all the tests are going to be taken in the testing center. Because it shows me that one, you don't look at your notes or listen to class or both. So again, don't just copy. If you're going to copy, at least do something with it and look it over. So again, I don't want you guys just to be rubberneckers. Let's finish up chapter 1, section 6. So we learned how all those about inequalities. Now we're going to look at absolute value and inequalities. So let's first look at what it means to be equal. What does the absolute value really tell us? If I drop the absolute value sign, what does A equal? In other words, if I had absolute value of X equals 3, and I drop the absolute value sign, what does that mean?
You said drop?
Because I'm solving for X. So the only way I can get X by itself is I have to get rid of the absolute values. When you drop the absolute values, what happens to the equation? Notice, think of this. What can X be to make it equal 3? No, absolute value of 1 is not equal 3. Okay, it can be 3. Can it be anything else? The absolute value of -3 is what? Negative is +3. Because the absolute value sign the number inside, it's a value. The number inside the absolute value sign becomes positive. Because the absolute value is a distance. How far is that number away from 0? So if we look at this, if absolute value of X is equal to 3, that's 3 units away. Well, it could also be the other direction also. Since it is a distance, left or right, it's got to be 3 units away. So when you drop the absolute value signs to solve for X, the answer becomes plus or minus 3. That's how you would write it. Or I could give it to you this way. What number is 4 units away from 0? That's really what it's saying. What number is 4 units away from 0? Yeah. This is 4 away, and that's 4 away. So the number I could put in there could be plus or minus 4. So the formula is this. When you drop the absolute value sign, the answer becomes a positive or a negative. So now we have inequalities to look at. Let's look what this means. Remember what I said last time, when you solve absolute value equations, treat it like an equal sign. So what would be my numbers here? A or negative A? Because that's how far it is from zero. So now we're looking at this. Now we have, instead of equal sign, now we're looking at that. X is less than A. So that here's A, and it's less than A. So it goes all the way to zero. So what this thing says is it's going from my number to the zero, to the inside. So what do I do from negative infinity? Because if X is going to be, if I'm now going to go to negative A, that means I got to change this direction also. So it's also going to be greater than negative A. So the formula for less than in inequalities is that. Whenever your symbol is less than, that's what it translates to. And it's either going to be less than or less than equal to it, whatever the sign is, the sign is. So what's that answer going to be? There's no equation really. I just drop the absolute value sign. If I drop the absolute value sign, X is going to be less than 4, or it's going to be greater than negative 4. Again, use the formula right there. Whatever numbers on this side goes here and here with a negative. Good morning. Oh, there's a sheet back there, Janet. If that one took you a long time, work this one out. All right. So as this example here showed, if I have absolute value of X is less than some number A, that means from wherever A is, it's how far to zero. I also have to look at from the negative side. How far is it from zero? It's A units. So when I drop the absolute value sign, there's nothing around there. So I could drop if I drop the absolute value sign, that means I have both sides. I have the -7 and the +7. That's what this formula tells you. When you have absolute value is less than a number, when you drop the absolute value, it becomes this. There's nothing else in between. So now solving for x, we subtract 3. -7, negative, they're both negative. So we add them. 3's cancel. 7 minus 3 is 4. This one could be written as this, or it could be a graph. Like that. You have to know how to write all three forms of this number. All right, the next example. Until everybody gets it right. Are you sorry? You should be. There's not much to this one. Everybody should be finished already. What's the answer? So drop the absolute value sign. X. This stays the way it is, but I need the negative side. Okay, do that one. You should be done. What's the answer? Absolute value can it ever be less than a negative number? Trick question. I like to build your confidence up and smash it. No, I just see if you were paying attention because remember, absolute values always give you positive numbers. It cannot be less than a negative number. Because there's no way this number can be negative, period. Hmm. That's a mistake. Oops. Remember, the formula, it's a less than. The formula is this. Now, what does that formula mean? We have to get the absolute value by itself, has to be less than a number, less than equal to. Once it's equal to a number, then we can do this. We can't split it up just yet. So we have to first get the absolute value by itself before we can use the formula. So simplify the equation so that the absolute value sign is alone on one side. That's the first step. So we have to look at this left side. What do we have to get rid of first? Get rid of the 5. Get rid of anything. Remember, it's the same as it's the same as if we had this. What would you do first? You'd add 5 first. So we do the same thing here. We add 5 to both sides. Then what? Is the absolute value sign by itself? Yeah, there's a 2 in front. We have to get rid of that. Because it has to be naked. So we have to get rid of the 2. There can't be anything in front of it, behind it, above it, below it. Can't be anything anywhere. So we have absolute value of x minus 3 is less than equal to 10 divided by 2 is 5. Now apply the absolute value rule. This one up here. To remove the absolute values. So what the rule says is I have the absolute value by itself. Inside here could be an entire equation. I'm just saying that's what it is. So when I drop it, I have this equation. So whatever is over here, I put a negative in front of it and positive. So I have a negative 5 and a 5. Whatever's inside there goes here. Now we do what? Right. Now we solve for x. So we add 3 to everybody, to all 3 sides. Negative 5 plus their opposite signs. 5 is bigger, so the answer is negative. 5 minus 3 is 2. 3's cancels. We have x. 5 plus 3 is 8. And there's your answer. And these are the other representations. Get used to putting in all 3 representations. So far, so good. So that's the less than rule. Let's look at greater than. Absolute value of x is greater than a. So if we drew this on a map, on a graph, remember, absolute values represent a distance on how far that number is from zero. So what does x greater than a mean? Is it open or closed circle? In this case, it's open. Which direction does the arrow go? It goes to the right. So this one goes to infinity. That's the positive side. Now we have to look at the negative side. So it's going away from zero. So this one is going to negative infinity. So to finish this, what this represents is x is less than negative a, or x is greater than a. That's what happens to that one. So in this example, I drop the absolute value sign. X is greater than 2. I'm sorry. Or x is less than equal to negative, which is what this meant, but I don't want to get y'all confused. Because what this says is -2 is greater than x, and x is greater than 2. It means the same thing, but it's written really weird. So I'm going to this format. So leave this alone, just drop the absolute value sign, or you flip the sign and the inequality. So when you change the answer to negative, you got to change the direction of the inequality. All right, setting it up should be pretty quick and easy. Drop the absolute values. So we have x minus 3 is greater than 5. Since it's greater than, there's an or. X minus 3 is less than negative 5. Add 3 across the board. X is greater than 8. Or x is less than negative 5 minus 3 is 2. They're both open. X is greater than 8 goes that way. X is less than negative 2 goes that way. If you think about it, both of these rules are mirror images. The answers are mirror images of themselves. I'll show you what I mean. Fold my paper in half. So the first one, we have x is less than a. What that says, the graph, here's 0, here's a. X is less than a. If I fold it over, here's negative a, and it goes inside. So negative a is less than x is less than a. That's what that says. The absolute value of a is x is greater than a. Here's 0. There's a. It's greater than, so it's going to the right. And if I fold my sheet over, I got a imprint on the negative side. It's a mirror image. So x is less than negative a, or x is greater than a. And that's all there is with absolute values. Pretty straightforward. Any questions about chapter 1? Okay, so let me write, this is the end of chapter 1.